In an arithmetic sequence, the second term is 7, and the sum of the first 5 terms is 50. Find the common difference of this arithmetic sequence. So if we set up two equations using the nth term, so 7 is the first term plus n minus 1, in this case n is 2, times d. So that's that. And then for the sum, we have 50 equals n over 2, 2u1 plus n, which is 5 minus 1, 4, times d. And then just tidy that up. So distributing, we're going to have 5u1 plus 10d, and just dividing by 5. So now we can use elimination. So if I write this one over here, I can subtract. So we're going to have 3 equals d. And when we substitute that back into either one, I'll do in this one. 7 is u1 plus 3, so u1 is 4. All right, an 81-meter rope is cut into n pieces of increasing lengths that form an arithmetic sequence with a common difference of d meters. Given that the lengths of the shortest and longest pieces are 1.5 and 7.5, find n and d. So we know that all of these are going to add up to 81. So we can have the sum, first of all. So n we don't know, over 2, 2u1. Actually, we can use u1 plus un, so 1.5 plus 7.5, because we have the first and last. Okay, so that's 9. Oops. This is 9n over 2. And when we multiply by 2 and divide by 9, so 2 over 9 times 81, that's going to be n. So we have n is 18. And then to find d, we can use the fact that un equals u1 plus n minus 1 times d. Oh, and we have n is 18 actually, so this is 17d. So when we subtract 1.5, we're going to get 6 is 17d, so d is 6 over 17. All right, so the first of 4 terms are that, or a and b. Okay, so we know the difference in between so u2 minus u1 is going to equal u3 minus u2, and we also know that u4 minus u3 is going to equal u3 minus u2. So we'll get simultaneous equations. So a minus b minus 2 is 2a minus a, which is a, and b minus a negative b, which is plus 2b plus 7. And then we'll just, okay, those will cancel. Okay, this is not bad at all. So we'll add b, and we'll subtract 7, which is negative 9. So we have b is negative 3. And down here, we have a minus 3b. Hold on, we'll just combine right away. So a minus 2a is negative a. minus 3b minus b is negative 4b, and we have minus 7. And here we have 2a minus a, which is a, b plus b, which is 2b, and plus 7. So we have, we'll get the a's on, we'll get everything on one side. So we'll have 2a, 6b, and I'll just get the 7 over here, so that's negative 14. So if b is negative 3, that's going to be minus 18. So if we add 18, that's 4. So a should be 2. All right, 42, write down the first 3 terms. Okay, so we have n is 1, so 3, n is 2, 6, n is 3, 9. So that's A. And then B, we have 20 terms. So we want the sum of 20 terms without graphing calculator. N over 2, and we can just do the first term, which is 3, and the last term, which is when we substitute in 20, which is 60. So we have 10 times 63, 630. And for double I, we can find the sum to 100, and then we'll subtract out what we found in BI, because we just want 21 to 100, so we'll get rid of 1 to 20. So, sum of 100 terms, and we have the first term is going to be 3, and the last terms when we substitute in 100, that's 300, and so that's going to be 50 times 303, so that will be 150, and we want to subtract away 630. So 14,520. The other way you could do that one is by finding, because you want to find all the terms from 21 to 100. So if you do 100 minus 21 plus 1, that's going to be 80 terms. So you have the sum of 80 terms. So n over 2, and then you need, you can do u1, which is going to be when you substitute in 21. So that's 63 plus 300. So that's another way to do it, which should give you the same answer, and it does. All right, 52 in arithmetic sequence has 5 and 13 as its first 2 terms. So we know D is 8. It tells us it's an arithmetic sequence. Write down in terms of n expression for the nth term. So we have un equals u1 plus n minus 1 times 8. You can also do it the other way with the correcting term. So for B, find the number of terms of the sequence which are less than 400. So that's when we substitute in 400 to solve for this. It's with graphing calculator, so I would use nsolve. You can also use the table, and you end up getting n is 50.375. So that's exactly that's when it's exactly equal to 400. So at the 50th term, it's less than. Find the sum of the positive terms. So we need to find when it's equal to 0. So the nth term is going to be first term plus n minus 1 times d, which is going to be negative 7. And we want to see when that's equal to 0, so use nsolve or the table. So n is 13.1, so at the 13th term it's greater than 0. After at 14th it should be less than. You can always check. So we want the sum of 13 terms. So 13 over 2. 2u1 plus 13 minus 1 times d. So this should be 559. Consider the arithmetic series, find the least number of terms. So the sum of the series is greater than 10,000. So we'll find when it's equal to 10,000. So we're looking for n over 2. 2 times u1 plus n minus 1 times d, which it's going up by 7. Okay, so n solve. So when you do n solve, you get, because it will be a quadratic if you distribute that n over 2 out. In n solve, you get negative 52, which is not good. Because obviously n has to be a positive number. So you can, after your x, put like comma, I don't know, maybe 50. And that's just luck. I mean, you could put 20. I just knew it was going to be a larger number. So, yeah, you end up getting n is 54.8, ... So the least number, so it's greater than, so at 54.8 it's equal, so the 55th term should be greater than 10,000. You can always use the table as well. All right, Mr. Jonas decides to increase the amount of money he spends on food by D every year. In the first year he spends A. In the 8th year he spends twice as much in the 4th year. Okay, sorry for this one. So we have in the first year A. In the second year he adds D. In the 3rd year he's adding another D, so 2D. In the 4th year he's adding 3D. And in the 8th year, he spends twice as much as he did in the 4th year. So we've got 4, 5, 6, 7, 8 is this one. And in the 20th year, he spends that. Okay, so U1, U8, and U20 is 4,000. Okay, so we can set up, so we've got U20 equals U1 plus 20 minus 1 times the difference. Okay, so that's something. And then so if this is U4, twice that is U8. Okay, so what I should have done is this is also equal to A plus 7D, isn't it? Because, it's U2, so D is always one less than the nth term. So for this one, I will distribute the 2. A plus 6D equals A plus 7D. So when we subtract A, we get A on this side, and we'll subtract 6D. So A is equal to D, so that means we should be able to substitute D in here as A. So 19D, so 20D is 4,000. So when we divide by 20, you should get 200. All right, 56, find the sum of all multiples of 7 between 200 and 1,000. So the multiples of 7 is 7n. If we want to know, we need to know the n's when it's equal to 200 which it won't be exactly equal, so we'll take the next one. So we need to find out when it's equal to 200 and when it's equal to 1,000. So when you divide these things, for 200 divided by 7, you get 28.5. So not until the 29th term is it in our range above 200. And if when you do 1,000 divided by 7, you get 142.8. And that means it's exactly equal. So before that, 142nd second term is before 1,000. So that means we want the sum from the 29th term to the 142nd term of 7n. And you can just do that in your calculator with your sigma. So x is 29 up to 142 of 7x. So you should get 682.29. All right, consider the arithmetic sequence from the value of the 11th term. So we want u11 equals u1 plus 11 minus 1 times the difference, which is 3, so 31. For B, show the sum of the first n terms. Okay, so we have n terms, and we have n over 2 u1 plus n minus 1 times 3, and just distribute out. So n over 2, 3n minus 1. Hence, find the sum of the first 100 terms. So we have to use that thing. 100 over 2, 300 minus 1. So we're going to have 299 times 100 over 2. So that's 14950. And D, the sum of the first n terms is that. So we have 477 equals n over 2, 3n minus 1. And when we multiply by 2, we're going to have 14, 15, 954, and distribute the n. So 3n squared minus n. So that is the first bit. Hence, find the number of terms. Since it's with the graphing calculator, you can use, if you go menu 3, 3. So menu 3, that gets you to the polynomial tools, and you want to find roots of polynomial. It's degree 2, so just push enter, and then you put in your coefficients. So it's 3, -1, and -954. Another way you can do this is graph it and find your zeros. Oops. So -53 over 3, which is not a possibility for n. It has to be positive, so we take 18. All right, 64. The first 3 terms of an arithmetic sequence are that. Show k is 4, so we have to do 5k minus 2. So u2 minus u1. And that should equal u3 minus u2. So 5k minus 2k is 3k, -2 minus 3, -5. 10k minus 5k, -15 minus -2 is -13. So we'll subtract 3k, add 13. So k should be 4. So that's A. B, find the values of the first 3 terms of the sequence. So what we substitute in 4. So 2 times 4, 8, 11. 5 times 4, 20 minus 2, 18. And 40 minus 15 is 25. So we know for C, D is 7. Because we're adding 7 every time. Calculate the 20th term. So we have u1 plus n minus 1 times d. Okay, So that's going to be 133 plus 11, so 144. And for E, we want the sum of the first 15 terms. So 15 over 2, 2 times U1 plus n minus 1 times the difference. So that is going to be, when I distribute the 2, the 1/2, that's going to be 11 plus half of 14 is 7, so 49. So that's going to be 60 times 15, which is 900. Okay, last one, 65. The first 3 terms of an arithmetic sequence are that when x is, when x is 3, the sequence is arithmetic. Write down the first 3 terms. So we have 3 squared minus 3, so 9 minus 3 is 6. Then we have 3 squared, which is 9, and then 4 times 3, which is 12, which makes the common difference 3. And for wherever B went, here's C. Find the other value of x for which the sequence is arithmetic. So that means x squared minus 3 should equal 4x minus x squared. So those cancel. And then this is 3. Getting everything to the left-hand side to make x squared positive. We get this. So factoring 2 things that multiply to 3 that add to -4, we need -3 and -1. So here's our 3, and the other one is 1. Okay, so for D, for this value, and C, write down the first 3 terms. So now we're going to have 1 squared minus 3, which is -2, then 1, then 4. That's making the common difference 3. And find the sum of the first 4 terms, which is going to be n over 2, 2u1 plus n minus 1 times d. So we've got 9, 5, 10.